Good morning. This session we are going to see about evaluation of storage architecture. First we'll see about the storage shortly. In your previous session we already discussed about the data creation process. Who created the data? The answer is nothing but individuals as well as business. Okay, business people can be created the data. Okay, now how the data have been stored in an effective way, that is what the main thing. Okay, so in this session we are going to see some of the storage mechanisms. So the examples, the individuals created data through digital camera or phone or DVD or hard disk, and the business data can be stored in your hard disk, external disk drives or tape library, whatever it is. Okay. General storage model can be categorized into three ways. One is centralized. It comes under the mainframe computer, and other one is decentralized. It is a distributed way, that is the client server model, and the other centralized mechanism is called it as a storage networking process. These are the different storage models, and this is what your storage technology and architecture evaluation. Initially we have internal DAS, that is DAS is nothing but your direct attached storage. You can directly attach your storage device to your system. And next level, it was improved as JBOD, that means JBOD, that is the next block. So it's called it as just a bunch of disks. Okay, so you can have the data in different disks. Okay, you can have the segmentation in your server. Okay, and next level it is called it as a RAID array, RAID, redundant array of inexpensive disk. Okay, and the next level it is called it as a SAN or NAS, storage area networking or network attached storage. Okay, so it can be connected to your systems through LAN or FCSAN. Okay, FCSAN is nothing but your fiber channel storage area networking. It's just for the faster communication. You can go with the FCSAN. And finally, you have an option IPSAN, that is a storage area networking over internet protocol. Okay, by using the IP, you're going to use the SAN device. Okay, so here you can have an option multi-protocol router is there. Okay, and through that you can able to connect it to your system. And these are the types of storages. Okay, so RAID, redundant array of inexpensive disk. Okay, so by avoiding the redundancy, okay, so what is that, through redundancy you can able to achieve reliability. That is what the formula. Okay, so generally we don't want the redundant data, but in case of failure, okay, so if you don't have the backup, it is very difficult to get back your system into the normal state. So in particular case, in such case, we can prefer the redundant information also. That means the same information is stored in multiple disks. Even if any one of the disk failure happens, we are not bothering about that. We can take the backup from the other disk. Okay, so that is what the formula. You can achieve reliability through the redundancy. That is what the concept behind your RAID system, redundant array of inexpensive disks. And DAS, direct attached storage, I said already, it is clear communication. That means you can able to connect your storage device into your system directly. Okay, so it may be what is it, defined in two ways, that is internal DAS and external DAS. All these things we'll see in depth in your upcoming classes, and we'll see first what is this DAS. Okay, so you can, it is very easy to connect your storage devices. There is no what is that, complex structure is there. Okay, and maintenance is also so easy. Network attached storage, that is simply called it as a NAS. Okay, network attached storage. Okay, so the storage can be directly attached to the network itself. Okay, and next one is storage area networking, that can be called it as a SAN. You can have the different types of SANs also, that will also see in depth later. And the next type of storage is nothing but your IP SAN. That is what in your previous diagram we have. That means you can have an option multi protocol router. Okay, so the storage area networking over the internet protocol. Okay, so that we can have that kind of storage IP SAN. And later this storage architecture can be divided into two parts. One is server centric storage architecture, other one is information centric storage architecture. What is server centric storage architecture? In the sense, for a particular reason, you can have a separate server. For example, I'm going to maintain 3 different departments information. Okay, so I need a server for each department. This is what server centric storage architecture. So department 1 server, department 2 server, department 3 server. I can divide the server information, I can divide the information into 3 different storages, and each storage is used for one particular department access. Okay, so I'm not going to classify any information inside this server 1. For example, department 1 server belongs to CSE department information, department 2 server is for IT department, department 3 server is for ECE department. In the sense, the whole IT department content and whole ECSE department content will be stored in one particular server. Okay, so I'm not going to divide the content. That means it is student relevant information or faculty relevant information or course relevant information. I'm not going to classify anything at all. Okay, so this is what a server centric storage architecture. Okay, and the next level, it can be again classified into information centric storage architecture. Okay, so based on information, I can able to access the storage. Okay, so once I stored the information completely in one particular server, okay, it's very, if it is large volumes of data, it is very difficult to access the information. Okay, it will take more time to access the information if all the data in one particular location. Okay, so if I have the partition in my server, okay, and this device is for student specific information, this device is for faculty specific information, and this device is for course specific information. If you have the partition like this, okay, and you have a partition number also, okay, so in the disk number, I'm trying to say the partition is nothing but the disk partition. Okay, so if you have the partition like this and you have a specific number, you can directly go and access the particular information. Okay, so the next level, you can divide your data as information centric storage architecture. In right side, you can say the department 1 server, 2 server, 3 server, all connected through a storage network. Okay, and there is a connection to your storage devices. You can have the number of disks here. Okay, there are 6 disks shows here. Okay, based on the demand, the number of disks can be increased. Okay, so for each disks, we can have the logical numbering process. Okay, we'll see what is the logical number, all these things in your later classes. Okay, so how I can identify the disk, in the sense each and every disk is having a unique number, and based on this you can access your information. And this is what the server centric storage architecture. Okay, you can have a 3 different individual server, okay, for 3 different, for storing the 3 different departments, and this is what your information centric storage architecture. Okay, so all the servers can be interconnected by your storage network, and it must be connected to your disk storage part. And the overall summary, and we know what are the different types of storages are available, and what is the storage architecture, and its evaluation. Okay, so from your direct attached storage to the IPSAN. Okay, so the development of your storage architecture process. Okay, that's all. Thank you.